This video goes through the first design for activity 1.2.5 for those of you that either are absent from class on the day that we do this, and so you weren't there for the live demo, or if you got hung up with your computer restarting and the myriad of other things that might go wrong during class that would cause you to fall behind. This video will help you get caught up so that you can submit the work for this activity on time. So I am just going to follow along with the same directions that were done in class. And yeah, so here we go. We're going to start by going into the sketch environment by clicking on the green plus sign. And then as instructed, we're going to select the XY plane. Which of course is that green and red one that we've been using. Now, this particular sketch is asking us for millimeters. Now, if I go over here to my document settings and I click on that little arrow to drop down, my default units right now are in inches. So there are two options for switching the units over. One is to change the default units. The other is to actually type the units in every design that you're like every dimension that you're doing. The second one that you need to do are in inches. So I'm actually tempted in this particular design to go with the second option because I know that I'm going to have to convert back to inches, but we'll go ahead and change it anyway. We'll put our active units in millimeters. And so that is changed over. And I'm actually not sure. I think I didn't change my default. So if I open up a new sketch, my units default back to inches. So yeah, I feel pretty good about that. So this design will be in millimeters, but nothing else. All right, so the first thing it asks us to do is to sketch a 20 millimeter by 30 millimeter rectangle. And remember that we want to try to orient things around the origin. So I am going to start this. I'm going to use the 2-point rectangle and I'm going to click on the origin and just draw my rectangle out. And then I need to dimension it. So this is a 20 millimeter by 30 millimeter rectangle. So I'll go ahead and dimension this side at, I think I want to do, I'm just thinking about how I want to do this. I'm going to do this as the 30 millimeter side. And this one as the 20 millimeter side. So you don't need to worry about like how big you actually make the rectangle. And I know in class some of you were paying like a really close attention to the scaling on this to try to get it to be right. You can do that, but it's generally not very time efficient because you're going to have to dimension it anyway. So it's just faster to like slap that rectangle on there and and then just dimension it, because even if you're at 30.01, like that's still not the right measurement. And if you were designing like a wing for an airplane or something, I mean, that's enough to cause your plane to crash. So you need to dimension it anyway. Just get the rectangle up there. Now the next step says to finish sketch. You can click either down here or up here to finish your sketch. And the next step says revolve the rectangle 360 degrees around the 30 millimeter side. So I come up here to my revolve menu, revolve option, and I'm going to select this profile. And it doesn't say like which of the 30 millimeter sides, but because I want to try to keep things centered around the origin, I am going to pick this one here. And so we revolve it around and that looks pretty good. All right. Now, the next step says sketch a 10 millimeter square centered on the top of the cylinder. So I'm actually going to turn my object. So if you can't see where my mouse is, I'm grabbing my view cube up here and I'm turning it around so I can see this side. And I'm going to click Create Sketch and then click what I want as the top side. So now it's going to allow me to draw on the top side. Notice that when I hover over the center or over the origin there, because of the way that I drew my rectangle, and this is why we want to not just put like a rectangle wherever, okay, is because now I can use the origin to make sure that my square is centered appropriately. So I'm going to use the rectangle. Now, it says that I want a rectangle centered on the top of the cylinder. While I could use a 2-point rectangle, okay, and then dimension that from the origin to get it centered, that's not actually the most efficient way to do it. And this is where it's beneficial to know what tools you have available to you. So I'm going to click in that create menu, come down to rectangle, and I'm going to use the center rectangle. If you need your rectangle centered somewhere, that's the option you want to use, and you want to know that that option is there. Now I can click on the center of the circle and just slap my rectangle there, and I automatically know that that rectangle is centered where I want it to be. For those of you that have done geometry, you'll notice the diagonals just drawn in there, and you know from your geometry theorems that a rectangle, one of the properties of a rectangle is that the diagonals are congruent and they intersect at the center there, and so that's what Fusion is showing us. Okay, now I need to dimension this because it needed to be a 10mm by 10mm rectangle. So there's two ways I can do that. I'm going to go ahead and dimension this to be 10mm. So now I know this is correctly done. I have two options. I could also dimension this and drag it out and have it be 10mm, or I can use what's called a constraint. And I can put an equal constraint on this and say, okay, I want the horizontal and the vertical sides to be equal. And so what that did was it took this side that was already dimensioned at 10mm and said, make this side equal to it. And that will, what that does is it forces this to be a square, okay? So even if I go in and change this dimension and I make this like 20, notice that it changed the other side along with it because I put a constraint on it that said these two sides have to be equal. And where if I had just done the separate measurements, I'm going to make sure I put that back at 10. If I had just done the separate measurements there, it would have changed just one dimension and not the other. We have a whole lesson coming up on constraints, so there'll be more on that, but I thought this was like a good time to introduce that idea. All right, and now my directions say to go ahead and finish that sketch. Now I need to extrude the square 15mm to create an additive feature. So I come over here to extrude, and I want to choose the square, and we would like to extrude that 15mm, and that creates our additive feature there. And now we're adding a 5mm fillet to the edges between the rectangular prism and the cylinder. So when you're reading these directions, read it slow enough so that you know what you need to do. Add a fillet. Now I'm going to show you what a fillet is. So I'll show you where to find that tool. And you're doing that between to the edges. And there seems to be some confusion about this in class. So if you look at where my mouse is highlighting, that's a face, okay? So that's a face, a face, a face, a face. The edges, okay, now you've got an edge. That's an edge, that's an edge, edge, edge. So we need to know that vocabulary. Those of you that either have had me for Algebra 2 in the past or you have me now, know that I'm so big into vocabulary, because if I say edge and you're not sure what an edge is, then we'll have an issue. And then you have your points, okay? So there's a point and another point, and we have a point over there. So we have faces, we have edges, and we have points. And we are going to add this fillet to the edge between the rectangular prism and the cylinder. So there's my rectangular prism, and here's my cylinder. The edges between are this edge, and then to go see the other edge, I have to grab that view cube and rotate it around. Okay, so those are the edges. Here's where you find your fillet tool. It is in the modify panel. And a fillet is just kind of sanding down the edges. And again, Fusion is really good about this. If you highlight over, you hover over it, it'll kind of show you like this is what a fillet is. It's like sanding down that sharp edge. So we want to apply this fillet. Now, it's going to, we want a constant radius, and then tangent chain just means that if you select multiple things, it's going to fillet all of it. And it's asking us the edges, faces, or features that we want to fillet. I've got 4 edges. So if you've watched the video or you've been in class, you know, the last thing we talk about is the modeling efficiency. If I have to apply this fillet to 4 edges rather than click fillet and then, you know, do one edge and then turn my object and then do the next one, I'm going to click all 4 edges and then apply the fillet at once. So I'm going to click this edge, and now I do have to turn my object to go get the other ones. We want this edge right there. You need to be using a mouse to do this. This is not intended to be done with the touchpad. And then you'll notice my dialog box opens up right here. And so here I can put that 5mm fillet in there. And then to reorient my object, I'm going to click that little house button. I'm over in the upper right if you're not sure where my mouse is. And it's the right view. It's not. There we go. And you can see what we did there. We did a 5mm fillet to that. And then the last thing it asks us to do, I'm down here with step H. It says add a 5mm 30-degree chamfer to the bottom of the cylinder. That's this edge down here. If I kind of tip this around, here we go to the bottom. And so you might be saying, well, where is chamfer? Chamfer, you can go in your create, and I don't think there's a chamfer there. No, like that's chamfer is more modify than create. You're not creating something new, you're modifying something that's already there in your design. And fillets are kind of like chamfers. They actually have a pretty good like picture of it there. A fillet is like sanding it down so it's rounded. A chamfer creates a new face by angling it. So we're going to chamfer, and we want to chamfer the bottom of the cylinder. So we'll click that. And we want a 5mm chamfer. So I'm actually going to come over here, 5mm chamfer at 30 degrees. Distance value is equal. I think we're okay with the 5mm. I think it's going to automatically be the 30 degrees because it's not giving us the option. Oh, distance and angle. There we go. Type distance and angle. So there we go. Nope, it wasn't at 30 degrees. So we need to pick distance and angle. Glad I thought to look. There we go. There we go. 30-degree angle. And click OK. And there we go. Now, to demonstrate that you have designed this correctly, we are going to save your design and then create your PDF drawing of it. So I'm going to go ahead and I'm going to just do from design. I think it's going to ask me to save it. So this is activity 1.2.5 first design. And for some reason, all of my stuff is in pen design. Like that's where all of my stuff goes. Pen is another project that we're going to do. Okay, so we're going to create a drawing. We want the ASME. If you don't pick ASME, you end up with your orientation of your isometric is not what it's supposed to be. And then we're picking a sheet size A, just because if I decide I want to print your PDFs, it'll let me do that. All right, so we're going to come over here. We Fusion is going to think. And we have to see if it's giving us the, now that is not the view we want for the front. Remember, your front has to be the side, it has to show the longest dimension, and it has to show the most distinctive shape. And this clearly isn't the most distinctive shape. So we want to choose that. Now, last time choosing top is what worked. So that's the view with the most distinctive shape. And then we have our 1-to-1 I'm gonna change that. That's a little bit big. Let's do 0.75. I like that. What I did was I just changed the scale factor there. And what I'm doing with that is I'm trying to make it look nice on the page. And so then we'll click OK. And then we want our projected view. So I click my parent view. Now for this, we only need the top and the isometric. We don't actually need the right view. There's no dimensions on that right view. And then please left click, then right click, and then turn your isometric into a solid. And close that out. Now we want to do the dimensioning on this, and you can actually copy the dimensioning exactly from the sheet. Okay, so you shouldn't be like on the activities you guys just did. There was quite a bit of I'm gonna zoom in so I can grab this. There was quite a bit of over dimensioning happening, and that shouldn't happen because you just needed to copy the dimensions from the PLTW document. And that's literally what I'm doing right now. I'm not really even thinking about it myself, and you can kind of watch. So my dimensions are just going to match theirs. And I'm going to put this over here. I actually don't like it. They put that dimension up in the corner in the margin, and they didn't need to because it's just as easy to put it down here. All right. If you have trouble grabbing the right things, that's where you want to like zoom in. And I am just using the scroll wheel on this. All right, let's keep dimensioning. We have a radius of 5. So I'm going to put that dimension in there. Whoops. There we go. The distance from here down to here is 15. We're going to drag that dimension out. And then from here down to the very bottom is 30. I like line that up. Then we have this to this. Nope, that's not what I wanted. I did not want the diagonal dimension. Okay. I'm gonna get the angle on here. Well, that isn't the one I wanted, but it'll work. Oh, wait a minute. There we go. I just had to drag it down. There we go. There's the 5, and then edge extension, dimension, angular dimension. There we go. Oh, wait a minute. Okay. I mean, that's okay. I don't like, it's in my dimension is sitting on there. So let's see if it will let me move it. Let me escape out of that. There we go. Move that over so that it's not on there. All right, so and then what you'll do is you'll export this and email it to me, and yeah, I'm gonna have a lot of emails, but this pretty much just duplicates what was on the PLTW slide, and is the best way for me to know that this object was designed with all of the correct dimensions, because you're not going to be able to fudge that on there. So this video, about 20 minutes long, walking you through the entire thing. And then remember, for this activity, you also have another design that you need to do on your own. So this one is done as a class, and then the next one is done on your own. Don't forget that you need to have both designs done.